Okay, let's wait for 2 more minutes. Maybe we can start the class at 6:10 in case more people are joining because I only see 6 people, 5 people here. Am I audible to everyone? Just checking. Am I audible?
Yes.
Hello?
Yes, you are audible.
Yeah, okay. Thank you. Thank you. So yeah, let's wait for maybe until 6:10, 2 more minutes in case people are still joining. I don't see many people here. Okay, I think we can start. Maybe people can keep joining. I'll share the screen. Yeah. Okay, everyone. So, yeah. So, hi everybody. Welcome to this sixth week of the Joy of Computing using Python NPTEL problem solving sessions. So, as you all know, these are the sessions which are held so that you guys can have some practice before you solve your assignment programming problems of each week. So this week we'll be dealing with this week 6 material. As always, my name is Zenia. I am a PhD student at ISC, and yeah, we have been holding this session for 6 weeks now, so you should be knowing the drill by now. So again, all the relevant PPTs, I mean, sorry, the slides and the videos of the recordings will be made available to you, and I have collected all the links on my website, which is here. This is my email ID, and if you have any doubts, you can please email me. But please don't mail me things like asking me to check your assignment questions or anything like that, or asking me what should I do for this assignment question, stuff like that, because that is supposed to be tried by you. So apart from that, if you want some specific topic to be covered, or if you don't understand something in the class or the tutorial session, you're more than welcome to cover me. About the assignment questions, I'm being little strict because, as I've said many times throughout this class, the only way to understand programming is by actually going and doing the work yourself. So every time you're stuck, if you just ask for an answer, then it's not going to work out. So assignment questions, please be very sincere and try it yourself. But if you really have a very significant doubt, you can of course ask. But I would say that please try to always do it yourself without asking for help as much as possible. So in the week 6 lectures, you saw mostly about recursive functions or recursion, and also, you found out how to do this tic-tac-toe program, cipher program, and so on. So yeah, as always, I'm showing you the some good coding practices slide, because essentially, as I said to you, whenever you see your code should be written in such a way that someone who doesn't know anything also, they can very well understand by just seeing your code. So please try to have a good practice, because again, as I said, you never know, right? After 6 months or a year, you might go back and try to find the code, and that time, if you don't understand anything, there is no use of you having put so much work. So always try to keep some good names, file names, variable names, comments, white space, indentation, all that is very important. And in Python, indentation is quite important. If you don't indent your code properly, many times that will throw an error. So always be careful with that. So yeah, so let's today's one of the big topics of today or this week was recursion, where recursion is basically when you define a function or a process in terms of itself. So you can see how there's an infinite loop, right? Is this recursion? Is this recursion? And so on. The meme goes. Essentially, here when we define the function, we are actually calling the function within itself. So you have to keep defining it. Of course, it can't keep on going infinitely. So that's why you always need to have a base case with which you can compare. So can you guys give me some examples of some recursive programs that you guys did in the class, maybe? Those of you who are here in the class, you remember any program which employed or some program where you had to use this recursion concept? You can put it in the chat. Maybe I'll just minimize this so I can see the chat. Any answers, guys? Any examples where you used recursion in your classes? Anyone? Okay, so I think you do this exa did you okay, thank you. So factorial is one way place where you used recursion, right? Because factorial is something where you have to keep taking the multiple of yeah, you basically multiply or take the product of all of the numbers up to a certain number that becomes that number's factorial. So how do you use recursion in that point? Because you keep on calling the multiplication for every so f of n is equal to f of n minus 1 into something. So like that, you keep calling that function from the previous until you reach the base case, right? And what is a base case in the terms of the factorial? Because otherwise, if you don't define a base case, this will what will happen. It will keep on going infinitely. We need to know where to stop it. We need to define the function at some point, and that is what is called the base case. What is a base case for a factorial? Do you guys know? You understand, right? I can't just keep on calling the function forever. I need to stop it at some point. So I need a base case. So do you guys know what is the base case for a factorial? Yeah, 0 factorial is 1, or you can also use 1 factorial is 1. Yeah, either of those is fine as a base case. So that, it will keep on going. So suppose I take 5 factorial, so that's f of 5. So I will say that 5 factorial is equal to 5 into f of 4. So then 4, I have to compute 4 factorial. So 4 factorial is 4 into f of 3. Like that, it keeps on going until I reach that 2 factorial is 2 into f of 1. And I know that f of 1 is 1. So the loop stops there. Suppose I had not defined f of 1, then f of 1 will try to look for f of 0. F of 0 will try to look for f of minus 1. It'll keep on going, right? So that's why you should always have some sort of base case so that you don't just end up with the infinite sort of. Okay, so one other place where you can use actually is the Fibonacci series. So how many of you have, so I wanted to show you another place where you can use recursion is the Fibonacci series. So how many of you have heard of this Fibonacci series? Sorry. How many of you have heard of Fibonacci series? You can put your hands up or answer in the chat. Has no one heard of Fibonacci series? It's a mathematical series. Does anyone know? Series means not a TV show, like a series of numbers. Does anyone know what Fibonacci series is? Okay, so if you don't know, it's fine. Fibonacci series is a series of numbers where every number in the sequence is the sum of the two numbers that came before it. So I can show you exactly what it is here. So Fibonacci sequence or Fibonacci sequence. So basically, if I go to images, that will be probably better. So can you see that 0, 1, then the next number is 0 plus 1, 1. The next number is 1 plus 1, 2. The next number is 1 plus 2, 3. and so on, right? 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13. What will be the next number after 13? Can anyone put it in the chat? What will be the next number in the sequence after 13? 21, exactly, because 8 plus 13 is 21. So this is a very famous sequence in maths. It has a lot of nice properties. It's related to division ratio comes up in the universe, and in nature. So those are things that you can read about, or maybe you can explore in your own time. But point is that if you want to generate a Fibonacci series, suppose now I am able to just take the sorry, yeah. Now I'm able to just take the sum. But suppose I asked you what is the 30th number in the Fibonacci sequence, then I can't just sit down and write all the numbers 1, 2, 3, and then keep on adding, right? It will take me a long time. So you can write a program to find the Fibonacci series for any given number. And this is a program which actually uses recursion. So this is an example where recursion can be used, because again, what is the next number is the sum of the previous new numbers. But the previous number itself is the sum of the previous the two numbers before that, and so on until you reach the first two numbers. So the base case will be these first two numbers, and then we can generate the rest of the series using that. Okay, so this is why recursion is used. So I can show you the program that uses the Fibonacci series. So this is basically the program to print the Fibonacci series up to n terms. So here you can see that if n is less than or equal to 1, I'm just returning n. Otherwise, I'm summing the previous two numbers to n. So if it's n, I know that the nth term of the Fibonacci series is the sum of the previous two terms. That means the n minus 1th term and the n minus 2 term. So here you can see that if I enter 10 as the number of terms, then it will give me all the 10 up to 10, the first 10 Fibonacci numbers. If I run this program, you can see that it gives me 0, 1, 1, 2, then 1 plus 1, 2, 1 plus 2, 3, 2 plus 3, 5, up to the 10th number, which is 34. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it gives me 10 numbers. To be more clear, I can run it again. So this is the Fibonacci series. So again, you can see here that what is actually happening when I give 10, or let's give 5, for example, just for understanding. Okay, so this is the first 5 terms. So what actually happens is now I have recursive Fibonacci of 5, right? So in that case, now I have to, what do I have to do? I have to go to the fifth. So here it's printing all 5, but suppose I only want to print the fifth element, right? So if I pass 5 here, then immediately it's not less than 1. So it will go here. So it will say, okay, 5 means I have to print recursive Fibonacci of 4 and recursive Fibonacci of 3. I have to sum them. But I don't know what that is. So I go back, I calculate what is recursive Fibonacci of 4 and recursive Fibonacci of 3. So that again brings me here. If I calculate 4, I find that it is 3 plus 2, third term plus second term. If I try to calculate the third term, I find that it's the sum of the second term and the first term. If I try to calculate the second term, I find that it's the sum of the first term and the zeroth term, right? Or, because second term will be 2 minus 2. So now I know what is, so here the base case is clearly defined that if n is less than or equal to 1, that means if it is 1 or 0, then it just returns n. Because if you see, the zeroth term is 0, the first term is 1, and then it goes on in the sequence. Okay, so that's why the base cases have been this is basically your base cases. Okay, so does everyone understand this program? Is there any doubts in Fibonacci series? So this is a way in which you can calculate the Fibonacci series up to n terms. Any doubts? No. Okay, great. So I hope you all understood Fibonacci series and recursion in a different way, because I think you did factorial in class. So I wanted to show you a different example of the recursive function. Okay. So now let's do the question. So as usual, I'll show you the question and please answer in the chat with the option A, B, C, or D, and then I'll show you the answer. So here's the first question. Okay. What is the output of the following code? So just remember what we just now did, and whether that is useful to you or not, you can think about. Yeah, this is very much related to what we just now did. So please put your answers in the chat. I'll give you a few minutes. Do you guys understand the question? Okay, you say D. Any other answers? Vandana, can you tell me what do you think that this program does?
Yeah, so I feel like we are defining a function mystery having the parameter n, and
Hmm.
if n is less than 2, it will return n. Otherwise, it will return n minus 1 plus n minus 2. So
Right.
n is 25.
Huh.
Uh, oh, yeah, I missed it. So it's calling a function within a function. So it's a
Yes.
recursion.
Yeah,
Yeah,
it's a
but
recursion.
yeah, so my answer is wrong. And
No, no. So try to relate this with what we just did. Ye-
yeah. So, the first time it will call 25, and it
Yes.
will add 25 minus 1, that is 24 plus 23.
No, no, no. It will
And
not add 24 plus 23. It will add mystery of 20.
okay,
Hello?
yeah,
Yeah, yeah. So
yeah.
it will call. Okay. So I think there is some noise in the background, not able to hear you properly. But what I wanted to say, it will not add 24 and 23. It will add mystery of 24 and mystery of 23. This is recursion. You should be very careful. Now remember what the program which I just showed you, Fibonacci series, right? So this is also a program which calculates the Fibonacci series. Okay, someone else has given option B. So I started explaining. So let me just go to the answer. The answer is actually option B. So actually, can you guys see this is exactly the program which gives you the Fibonacci series. It's the same as this program, right? Instead of writing n less than or equal to 1, they have written it as n is less than 2, which is the same condition, right? N is less than 2 means n will be 1 or 0, and less than or equal to 1 also means n is 1 or 0. So this simply will return for, if I give n is equal to 25, this will simply return to me the 25th term of the Fibonacci series. So let's see what that is and if it matches with the answer. So 25th, sorry. 25th Fibonacci number, if I search, it's actually 75,025. And that is exactly the option I get. Is this clear to everybody why this is a Fibonacci series? Basically, just if you don't understand the program, try to put n is equal to 5 or n is equal to even 3. Let's start with n is equal to 3. right? Mystery of 3 will be mystery of 2 plus mystery of 1, right? Now I need to know what is mystery of 2. So for mystery of 2, it goes back. N is not less than 2. So mystery of 2 should be mystery of 1 plus mystery of 0. Now mystery of 1 is just 1 and mystery of 0 is just 0. So it will be 0 plus 1 plus 1 more 1, because mystery of 2 is just 0 plus 1, right? And then mystery of 3 will be 0 plus 1 plus 1 plus 1, like that. Is this clear to everybody what is the answer and why this answer came? This is a Fibonacci series. Is this clear to everybody? Yes or no, guys? I can explain it again if needed.
Please explain once.
Okay. So, did you all understand this program?
Yes.
So, what is the difference between this program and this program? Is there any difference?
N less than 2.
N less than 2, and here it's n less than equal to 1.
Yeah.
They're, they're both the same thing, because this is going to go up to 0, right? So 0 and 1 are less than 2.
Okay.
Instead of, suppose I write less than 2 here, it's the same condition, right? So
Yeah.
look at what the function is doing rather than this n less than 2 part. What is the function doing? It returns, or it adds the sum of the previous two numbers. I mean, this result of the function on the previous two numbers. That is exactly what this function also does. It's just that this function is called Fibonacci, so you are able to relate it, but this one is called mystery, so you're not able to relate it, right? So
Yeah.
this is just calculating the Fibonacci series. So if I want to know the answer, I can just search what is the 25th Fibonacci number and I get the answer. This is clear to everybody?
Okay. In
If this
exam
is,
hall, we calculate without the calculator, and we won't be able to Google search also for 25. We'll keep multiplying there
it's
in
not
the
multiplying,
exam.
it's actually adding. Fibonacci is adding, not multiplying. But yeah, they might not ask 25. I don't know what they will ask. But yeah, you have to just add 25 numbers. Does that take a lot of time?
Okay. Yeah.
Or the 25th number. So it will just keep, like you have to add basically, up to some point 1, 1, 2, 3, 5, 8, 13, 21, etc. So I think 34 is the 10th number. Do that a few more times. That is how you do it. But see, adding is simple. But to understand that that's what you have to do, that is the difficult part, right? You should understand when you see a function that this is a recursive, first of all, this is a recursive function. It's a recursive function where I keep adding terms together, right? Which means that this is a Fibonacci series. I just now showed the Fibonacci series to you guys. So you should have been able to you should have been able to correlate, right? What I just showed you with this program. You guys understand?
Yes.
Okay. So yeah, when you study something like in Python or generally, try to correlate with what you already know. Usually it will be helpful. Like don't study isolated things. That's just my general thing. So this is about this program. I think there are no other questions. I'm going to the next question, which is there. Are there any more doubts? So it's basically a Fibonacci series program, keeps going until when n is 2. So whatever number you start with, it will keep going back, right, until it reaches n is equal to 2. When as n is equal to 2, it gives you mystery of 1 plus mystery of 0. And then when it tries to calculate mystery of 1, it just gives 1. Mystery of 0, it just gives 0. So you get both your base cases back, and then it keeps on adding all the other terms, and you get n is equal to 25. Sorry, you get the 25th Fibonacci's term. That's what I meant. Okay, so that is what this program does. Again, you can try writing down this program in your system and running it, but the goal of this is not for that. You should be able to also identify some programs without running it in the first place. Never run code as a black box, right? Do you guys know what is a black box? So black box is something where you have a box and you plug a wire in it and it gives you some output and you don't know what's happening. You should never run code like that. If you're using a code or if you're doing something, you should always be very clear of the logic. Even if it is someone else's code, you should try to at least understand what that code is trying to do. You might not understand the full process, but at least you should understand this is my input and this is what it gives us out, right? So the what is the purpose of that code is always good to understand, and that's why I say write comments, because that will help you and it will help others also to understand your code better. Okay, so the next question is a simple question, which is the method in Python used to convert lowercase letters to uppercase. Please put your answers in the chat. I think all of you should answer. There are only few of you today. Eight of you are there today. I want 8 answers in the chat. Come on, guys. You don't have any calculation to do. I don't see any answers in the chat. Okay, one person has answered. Again, this is a there's no calculation involved. You should be answering immediately. Okay, option A, upper. Others? There are, I think, 8 people in the meeting. Yeah, I want answers from everyone. Are you all sleeping? Okay, one person says B. Others who are in the chat, sorry, others, please put your answers in the chat. Other people, are you not in the meeting? Okay, maybe we can go to the answer. Okay, I see someone is typing. They can type and I'll go to the answer. Okay. Okay, good. So most of you have said upper. Upper is actually the right answer. Capitalize is not really a function in Python. Please be careful. I can show you immediately here also. Wait, how do you do it? str dot. Or do you have to import some library for this? Okay, I don't remember. How do you use upper? Do you guys know? I forgot. Oh, okay, okay. Sorry, guys. I used it wrongly. I used it wrongly. I got it. So Python 3. Yeah, so you guys can see the screen, right? If I do ABC in small letters dot upper, then I get capital upper, ABC. If I do dot capitalize, there's no such option. So ABC dot upper is the correct answer. Okay, so this is how you use that function. Is there a doubt? Is there a doubt in the chat? If there's no doubt, I'm muting you because it's kind of distracting when you guys talk in between the class. If there's a doubt, please unmute and ask. But other than that, please don't unmute because there's echo and that's why. Okay. Okay, then fine. So next question. the min-max strategy, which you would have come across when you did this tic-tac-toe paper program in your class. So this is called the min-max algorithm. It's a decision-making algorithm using game theory and artificial intelligence. What is the primary objective of this algorithm? Can please put your answers in the chat. Again, there is no calculation involved here, so you guys should all answer immediately. And it's based on something that you did this week. I mean, maybe last week now, but yeah. Guys, any answers? Okay, one person says C. Others also please answer. There's no much calculation involved in this. You should be answering immediately. Okay, someone says option B, minimize the possible loss. C. Okay, I see most of you are, the majority is C right now, and then one person says B. The answer is actually C. So min-max does not just it cannot, you cannot just minimize the opponent's score. You take into account both of your score, and even if you lose, as long as your opponent doesn't win, that's how it is done in the min-max algorithm. And you would have seen this during the tic-tac-toe also, which is that even if you don't win, you should ensure that the other person, sorry, even if you lose, you should ensure that the other person does not win. So it will try for that. So it's like a zero sum game in sometimes. Okay, so please go and check that. This is basically for minimizing the possible loss. Okay, next question is about typecasting. So typecasting is basically the conversion of one data type to another. Python has various data types, which we have already seen many of them. But what is the output of this following code? Guys, answers in the chat. Anyone? I don't know why you guys are taking so much time when it's not even having to work anything out. Okay, someone says A. Someone says A. Others in the chat, any other answers? B. Other answers in the chat? Sorry. Okay, one more person says A. I think we can go to the answer. The answer is actually B. So those of you who said A, let's try it out, just to understand what's happening. Let's give a string, right? It's a string basically. So let's give int of 1, 2, 3, ABC, for example. You can see that there's a value error because it can only convert numbers to you can only convert numbers to integers, right? Whereas here you have this ABC part also. So it will not be able to convert. Whereas if I give something like 1, 2, 3, 4, 5, 6, then it will be easily able to convert it to an integer. So this ABC or Babu Moshai or whatever is given, does not know what to do with that. So that's why it gives me a value error. It's not a syntax error because syntax error means I wrote the command wrongly. It's not a name error. Name error means that I didn't call the correct variable. It's a value error because the value of the variable is such that it cannot be used into that data type. Okay, so that is the idea here. Does everyone understand the logic? And you can see, of course,
Uh,
the Python.
yes, yes, but it won't take the number part like 1, 2, 3 also.
How will it take that? So I have shown you right here. Like, how will it take
Yeah.
only that? How does it know how to take that? Doesn't take that. When you're asking it to
Okay.
convert a string, it's the entire string. That's why.
If there would have been a space after 1, 2, 3.
Why will it? The space is also not a number, right? Space is also a character. It's still not a number. Maybe it will work. Let's see if it works. Should give a value error. See again a value error. It should completely be a number. It's space is also not a character. It's trying to basically take the string and convert it into a number, right? Having a space does not help.
Okay.
Do
If
you
it
see that?
was different codes, maybe then, like if
Yeah.
1, 2, 3 is in different codes and the ABC is in different code, then maybe.
Yeah, so it has to be in two different variable names basically. 1 to 3 has to be in one variable name, ABC has to be in a one variable name. You can't even convert this. Suppose I have 1, 2, 3 space. That can be okay. 1, 2, 3 space is converted. That's very interesting. I didn't know that. Okay, so the problem is then not space. The problem is ABC. If you have any sort of letters, then it won't convert. Okay, somehow it's able to take care of space, but it's not able to take care of the letters.
Yeah, thank you.
Okay, cool. So that's about this question. Next question. This you should all answer immediately. Don't take time. What term is used in programming languages when a function calls itself? Because I just spoke about this in a lot of detail. I want everyone to answer this question. Okay, I see two people saying A. Okay, two people say C. Self-referencing, another person saying A. I hope you guys are all paying attention. It's actually called recursion. And I actually spoke about this at the beginning of the class, right? The term recursion is defined as the process of defining something in terms of itself. This is how you recursively call a function. We spoke about the Fibonacci series. We spoke about factorial. Please pay attention to the class, guys. This is not giving me a lot of confidence. Basically, this name, of course, self-referencing may be. What do you mean how? Ma'am, how? What do you mean how? This is the name. It's called recursion. This is the name that is given to this process. Please check your lectures also. They have called it recursion. And yeah, factorial, Fibonacci, these are all examples of recursion. This is the name for the specific process of defining something in terms of itself. Okay, please pay attention to the class, guys. I just spoke about this like not even 1 hour ago, maybe half an hour ago, right? Please pay attention. You can't have any doubts in this, I hope. This is just a definition of what recursion is. So it's not called self-referencing. There's a very specific name for this kind of function because they are very powerful. They are used in computer science a lot. These are called recursive functions. When you define a function like this Fibonacci function, if you look at the Fibonacci function, to define the Fibonacci function, we need the Fibonacci function itself, right? We define a function in terms of itself. That is what is called a recursive function. Okay. Is this clear to everybody now? Is this clear to everybody? Okay. Okay, please, these are the terms that you should be remembering, right? Of course, you can do it without knowing what it's called. But tomorrow, if someone asks you to write a function using recursion, you should not be confused as to what is recursion in the first place, right? So these are some terms that you should remember, like variable, iteration, recursion. These are different terms that is used in programming, and not every time they will explain what it means. So you have to kind of know these terms also. Okay. I hope that is fine for everybody. We can go to the next question. So this is a code question. Consider this following code that you can see here. What does this code do? What does the following snippet of code do? Okay, someone says B. Others? Okay, one more person saying B. Any other answers? Okay, B. Okay, one person says A. Okay, I see B, A, C, many different options in the chat. I'll give you maybe 1 more minute in case someone else wants to answer. Okay, one more person saying C. Look carefully what's happening. Okay. Okay, yeah, okay, fine. I can see your answer is B. So we can go to the answer. The answer is actually B. So again, look at the program very carefully. You can see that here it accepts a list as its input, and what you're actually seeing is it checks for the list items which are actually divisible by 2. Otherwise, it shortens the list by the first element and returns it. So every time you're kind of going through one by one the list element, and you're trying to find out this. So every time there's an even element, it adds 1. It does not add the value of that element, it adds 1, which means this is a counting function where it gives you the count of the even elements in the list. It does not give you the actual sum of the even elements. So here you can see that this is only for mod 2 is equal to 0. That's why I'm saying it's the even elements of the list. Is this clear for everybody?
Yeah, after else, what does this mean in the else part?
Okay, else part. So basically, it just tells you that if it's odd, continue doing the function. That's what it tells you. It keeps going until it becomes an empty list.
Okay, thank you.
Is there another question or something? Okay, fine. Okay, so this is what it does. If it's an odd function, it does not add it to the total. It just keeps going. That's what it means. Okay?
Yeah, understood.
Okay, great. So next is the next question is, so be very careful. It looks like it's the same question, but it's not. The code is slightly different. So be very careful. So if L is a non-empty list of positive integers, what is correct about the recursive of function of L? Okay, someone says D, others. Okay, someone says A. Others, I don't see any other answers in the chat. Okay, one more D. Any other answers? A, okay. I can see that there's no majority yet. There are two people who saying D, two people saying A. At least one more person answer so I can see what is the majority answer that people have. One more person, please answer so we can find out a majority. Okay, majority of you are saying A and majority of you are wrong. It's actually D. So does anyone want to explain to me what is the difference between this program and the last program? Why this is D, why this is the sum and that was the total? I told you these two programs are not identical. There is a change. One change is of course L percentage 2 is 1, which means that we are looking for the odd elements. But there is another change between this program and the previous program that we just now solved. Any of you can identify? Yeah, exactly. So if you notice here in the previous program, this is a previous program where it gave the total number of the elements and not their sum. You can see that every time I'm adding one, which means it's a count. Every time there's an even number, I'm adding one plus. So one plus, one plus, one plus, it goes like that. So it's just a counting function. Whereas here, I'm actually adding the element itself. I'm adding L of that element, right? I'm not adding the I'm not adding one. I'm adding L of that element, which means I'm actually adding the element itself. L of minus one. Exactly. So does everyone understand why this program and that program give different results? Of course, a very simple change is also that L percent, they are checking for the mod 2 is equal to 1, which means they're checking for odd elements, but also they're adding the element itself. They are not adding 1, which means it's not a counting, it's actually a sum of the elements. Does everyone
I
understand?
have a Yeah, I have one query. Like when we are saying if L minus 1, like index usually starts from 0. So what does the minus 1 index say
Uh-huh.
for a list?
So whenever you give minus 1 for any array, it means the last element of that array. So basically, suppose I have,
If this would be L0 or L minus 1, in both cases the output will be same.
yeah, I think so. It should be the same because it's just checking which are the odd elements. It's just n minus 1 is just they are taking. So previous case they were taking the first element each time and then reducing the list. This time they're taking the last element each time and reducing the list. That's all. You just need to
Okay, so
find a way
whenever we
to
have to, okay, every time for the last element in the list, we say minus 1 and 0 is the
exactly.
first element. Okay,
Exactly. So you can
thank
see
you.
on the screen, right?
Yeah,
Sorry.
thank you.
Okay, fine. Leave it. I had given it here. Forget about the other things, but yeah, basically n is 1, 2, 3, 4, 5. If I give n of minus 1, it gives me the last cell. So that's the idea. Instead of giving n of the number, which is whatever the number is, if you don't know what is the size of the list, if you give minus 1, it just gives you the last element. Okay, fine. So next
Yeah,
question.
thank you.
This we have done. Sorry, I'm going back. Sorry. This is we have done these two questions. Yeah. What purpose does a base case serve in recursive functions? Everyone answer immediately. No calculation involved. I also explained this at the beginning of the lecture. So let's see if you're paying attention. Okay. One person says C. Others. I want more people to answer, please. Okay. One more C. One person says B. Okay. C. C. Okay, fine. I think the majority answer is C. You're right. So basically, if I don't give a base case, then the function will keep calling itself forever and we'll get an infinite loop, right? For example, in this Fibonacci program, if I hadn't given this condition that 0 and 1 are 0, the 0th and first term are 0 and 1, then it would keep going back to minus 1, minus 2, minus 3, minus 4. It'll just keep on calling the function again and again, and there is no stopping the function, right? So we should always define a base case in recursion. Otherwise, it will just keep calling itself forever. So that is the idea why the base case is there. So yeah. Okay. So next two questions are going to be based on this code. Look at it carefully. The answer is just the number. What is the value returned by f of 10,000, for example? Okay. Try understanding what the code does and try like working it out if you can. And try working it out without just typing the code in a terminal or something. Try to understand what the code does. I'll give you some time. This can take some time maybe to understand. But yeah, look at the different conditions. This is a recursive function. You can see that f of n is defined in terms of f of n. So you have to take some steps to understand. Second, I'm just checking if the recording. Yeah, okay, it's being recorded. So the answer is just a number. Please put your answers in the chat. Okay, one person says 12. Others, okay, one answer is 7. Others, are you trying? Maybe I'll give you 1 or 2 more minutes and then I can show you the solution. So do you guys want to explain your logic as to what is 1 or what is 12? Sorry, what is 7 or what is 12? Whatever answer. What do you think that this function is doing? The people who answered, what do you think that this function is doing? What is the logic that you got from this function? Counting iteration of 5,000. You mean 10,000, right? Not 5,000. Yeah, so in some sense, this is a counting function in the sense that it keeps count of how many times you're going through the loop, right? You can see that every time it satisfies one of these conditions, it adds one, right? Until it doesn't sat until it becomes less than 1, at which point it just adds 0, which is the same as adding nothing. So every time it goes through the loop, it adds 1 to the answer. That means it's just keeping a count of how many times this function or this number goes through the loop, okay, until it reaches the value of 1. Until n becomes 1, it keeps on going through the loop, and every time it goes to the loop, it counts that. Okay, so that is what this function is doing. Do you all understand? Great. Okay. So maybe we can go to the answer. The answer is in fact 7. So someone had said 7. That is the correct answer, because let's try to count it, right? So we have 10,000. 10,000 is a, so what does this condition mean? This means that first we have to check if it's greater than 1. It is greater than 1. So this condition means that the square root is a perfect square, right? It's basically that means that there is no floating point part, so it's a perfect square. 10,000 is a perfect square, so 1 we can add. Then it takes the next step is to take the function of the square root of that. So square root of 10,000 is 100. So now it checks if 100 is a perfect square. Yes, it is. Again, it adds 1, so that's 2. Then uh 10 you have to give 1 plus square root of 10. Sorry, 10 is not a perfect square. Sorry, yeah. So yeah, 100,000, it's 100. 100 is a perfect square, so it does add 1. So 2. 1 plus function of 10. So 10 is not a perfect square. So now when it goes back, it goes to this condition, this else condition, because 10 is also not odd. This checks if it's odd. Then it adds one more, 3, right? Then then once it's here, it has to return 1 plus f of 10 by 2, which is 5. Okay, so again it goes back. 5 is odd number, so it adds here. So now we are at 4. We are at 4 passes, right? 100, 10,000, 100, 10, 5. At 5, it needs to compute function of 5 into 3, 15 plus 1, 16, right? So 16 is a perfect square. So now 5 iterations are done. 16 is a perfect square. Again, it checks 16 is a perfect square. Like that, you have to keep on going. And what you'll find is that there are 7 iterations in total that happen. So, and I have actually coded this up so that it becomes a little easier to visualize. So if you see, these are the things, and we can print x at every point so we can understand exactly how many iterations are there. So you can see that 0, 1, 2, 3, 4, 5, 6, 7. So it goes through the loop 7 times, and that's why 7 is returned as the final base case. Okay. Actually, it goes through 8 times if you count 0, but if you don't count 0, then yeah, it returns 7 times, and that's why 7 is printed as the base case. So, does everyone understand why this is 7? Because it goes through the entire process 7 times. Okay, is there a question? I can see a raised hand. Is there a question? Yeah, please go ahead if there's a question. Please go ahead. Okay, I don't know if maybe by mistake, but yeah, essentially this is a function where, it looks very complicated, where it seems like there's a lot of things happening, but actually all it's doing is it's counting how many times are you going through this process. So 10,000 becomes 100, 100 becomes 10, then 10 becomes 5, 5 becomes 16, 16 becomes 4, because 16 is the square root of 16, then 4 becomes 2, then 2 becomes 1, and 1 is of course 0. So that's how you get 7 iterations of this thing. Okay, that's how you get 7. So I'll give you one more question, which is the same kind of function. Here now you have to start with -8. So now you got the funda, you got what does this function do. So please answer what should be the value returned by -8. Please all of you work it out and return a number for me. I hope everyone understands what the program does, right? Everyone can understand what the program does. Is there any doubts in that? Okay, I don't see anything in the chat. Please stop me at any point if you can't understand. But now that you understand what the program does, please try to do this for -8 now. Okay, could you brief that once? Yeah, sure. Okay. So let's just look at the program once. Okay. Here you can see that depending on what number you start with, you have some complicated number which calculation which is done, and that calculations function they are taking, right? This is what is happening. So essentially what's happening is, first it checks whether my number is 1 or not. So 1 is my base case. F of 1 is 0. If it's greater than 1, then it first checks whether I have a perfect square. Because here you can see that this condition essentially tells you I have a perfect square. N to the power of half is it only has an integer part. It does not have any floating point or decimal part, right? If it's a perfect square, it adds 1. Similarly, it checks if it's not a perfect square, it checks whether it's odd or whether it's even, right? And depending on whether it's odd or even, it continues on with some process, right? So if it's less than 1, that is if it's some other number, 0 or a negative number, then it returns to you n squared. So like that, it keeps continuing. And you can see that at every point, what's happening is, even though we are calculating the function for some complicated form of n, like 3n plus 1 or n by 2 or n root of n, we are just adding 1 in every iteration, right? 1 plus 1 plus 1 plus 1 plus, which means what we are actually counting is the number of times it goes through the loop. Okay, so every time it goes through the loop until it reaches 1. So when we start with 10,000, first it goes through, and it is this condition which is satisfied, because 10,000 is a square, so 10,000 becomes 100 now. Now we have to find f of 100. Again goes through the loop, f of 100, we have to calculate as f of 10. Now again it adds 1, goes through the loop, f of 10, when we calculate, it's this condition, so then you have to now calculate f of 5. So it adds 1, 3, and it goes through the loop. Like that, it keeps on going until it becomes 1, and then the loop stops. So this function literally counts how many times you have to go through this process until you get 1. That is the solution. Okay. So now if I start with -8, how many times do I have to go through the loop until I get 1? That is the question essentially. Is this clear now? Okay, great. So I can see two people. There are two answers. One is 3 and the other answer is 4. So maybe I'll give you guys a minute or so, until a couple of minutes, in case 2 minutes, in case someone is still solving, and then we can go to the answer. I think you all got the funda now, what the program does. So just try to count how many iterations you need to reach to 1, and you can write the answer, and I can also show you through the program. Okay, maybe we can go to the answer. People who are trying, you can keep trying. So the answer is actually 5. So let's just verify again with the program. Answer is not 1, the answer is 5. So if I now run this with f is equal to -8, and see that it goes through the loop 5 times. So it starts with so the first condition that is satisfied is n is less than 1. So then we have to square it. We go to 64. 64 is a perfect square. So now you have counting in this. Now we are in the second pass in the loop. 64 is a perfect square. Now we have to find n is equal to. Now we have to find f of 8. F of 8. Now we go again in the loop third time. Third time we are doing f of 4. Fourth time we are doing f of 2. Fifth time we are doing f of 1. So when we reach f of 1, we stop. So that's how it goes. Okay. I hope everyone understood why it's 5. Start with -8, then you are finding f of 64. Then you try to find f of 8. Then you try to find f of 4. Yeah, f of 4. Then you try to find f of 2. When you reach f of 1, the loop stops. So it's 5 times that you go through the loop. Okay. Great. So yeah, be very careful with these kinds of things. Recursion can be a little confusing. So try to always write it down in a piece of paper so that you understand what's happening. Okay. And these kinds of counting is very good. Like if you count what is the exact loop and what n takes value. Okay. Okay, fine, great. So now we can do the programming assignment. So as always, I'll show you the program. I'll give you a few minutes to try to work it out on your own. We have 4 programs today. I don't know if you'll have time for all of them, but as usual, I will be uploading every programs on the Google Drive. I hope you all know how to access it. I'll give you the link at the end of the class. But yeah, I have been uploading all the programs, including those assignment program, Fibonacci series, all of them I'll be uploading on Google Drive. Please go and take a look. But always I'm telling again and again, please try to write programs on your own, and that's why I give you this time during the live sessions also to try and write a program on your own, because that will really help you to gain your programming skills, and of course in the course also. Okay, so keep your laptops ready. This is the first question. It's a little long, but basically, you can define something like the distance between two letters in the English alphabet, which is one more than the number of letters between them. Okay, so this is an example that is given where to go from A to A is zero because you don't need to move at all. A to C requires two letters, right? A and B. So the letter distance is two. A to Z requires 25 letters. Z to A requires 25 letters. E to A means B, C, D, A. So four letters. Like that, they are defining what is the distance between two letters as the number of steps needed to go from one letter to the next letter. Okay. So now they want you to define something called the distance between two words, right? Where if it is minus one, that means the words are of in unequal lengths. Sorry. But if the word lengths are equal, that is, we take two words of equal number of letters, then you take the sum of the distances between this. So suppose the difference between dog and cat, you take the difference between D and C, the difference between zero and sorry, not zero, O and A, and the difference between G and T. And you take the difference between each of them, use this formula, calculate it, and add up. So write a function named distance that accepts two words as arguments and then returns this distance between them. Okay, there's a question in the chat by Vandana. Guys, please work on this. Let me just look at Vandana's question in the meantime. Yeah, what's the
Yeah, so
question?
actually, I want to ask, like, here we are defining an array, then we are sorting it, then in n we are taking the length of the array, then
Mm-hmm.
to define the kth smallest and the kth largest like element, it's written like kth smallest is equal to array k minus 1 and kth
Yeah.
largest in the array is minus k. What does this mean?
So do you know what kth smallest and kth largest mean? This is the issue. Do you know what that means? Is that the
Yeah,
issue?
why are we? Yeah, so this is an array which has multiple elements. So for finding the smallest element, we are saying we are
No, no,
giving
no.
the
This is not the
index as.
this is not the smallest element. This is the kth smallest element. That's different, right?
Okay, so kth smallest means like it's a sorted list because we are
Yeah.
sorting it.
So kth smallest means suppose you have a number like 1, 2, 3, 4, 5. Okay?
Okay.
Okay. So what is the first smallest number? It's 1. What is the second
Yeah.
smallest number? It's 2.
So according to Python, the zeroth smallest will be 1 and the first smallest will be.
Exactly. So that's why you have to give k minus 1. Because Python does not know first smallest number will be. So why do you sort the array? You sort the array so that
Okay,
it's already in
okay,
the order.
okay.
Okay. The first
Yeah,
smallest number will be at 0. The second smallest number will be at 1, and so on. And if you want to read the array
okay.
backwards, as I said, minus 1 is the last element, minus 2 will be the second last, and so on. So that's why they do minus k. Do you understand?
Yeah, yeah, got it now.
Okay.
So
That's
this will give the largest, that is the minus kth, that will be the largest.
Yeah, minus k means you're
Okay.
reading the array backwards because you want the largest
If
element because it's
so,
sorted.
k is the total number of elements in that array.
No, no, no. K is not the number of elements. N is the number of elements in the array. Be very careful. Kth smallest, which means I give you an array and I'm telling you find the second largest number in that array. Is two
Okay,
the
so
number of elements?
k is the position.
K K is, yeah, K is a position. K is the number which element you want to find. If I tell you second largest number in the array, what is K?
2.
2. Exactly. So that is what it is. You get it?
Okay,
And do you
understood.
understand
Yeah,
why we
yeah.
have to sort it first? Because if we don't sort it, we can't say anything like smallest number is here or largest number is there. That's why.
Yeah, yeah. So this way, after sorting, the last element will be the largest, and so we are taking the minus kth.
Exactly. And if I want to find second largest, I have to take just one before the last, and that will be -2. So that's how you do a element in, that's how you read an array in reverse. Okay?
Uh, so then why are we taking minus k? It shouldn't be -1 here then.
-1 is if I ask you to find the second largest element. If you give me the
Okay,
last
okay,
element,
okay.
will it be correct? No,
Understood.
right? You understood.
Yeah.
Okay, good.
Yeah.
Okay, I hope
So you
everyone
were
else.
giving that you were giving that example of -2 na, so I didn't get that one of -2.
Yeah, because okay, let's just okay, sorry, one sec. Let's try to understand. Sorry. This is already sorted, right? I don't need to sort it. Okay. Now tell me which is the
Yeah.
second largest element of this array.
3.
Which is the second largest element of this array? I'm telling the number, not the position.
Okay. Yeah, say 2.
No, 2 is not the. Okay, you know numbers, right? Is 4 bigger than 2?
Oh yes, 4 is bigger than 2. Yeah.
4 is not the biggest element. 5 is the biggest element. 4 is the
Yeah.
second biggest element. Okay.
Yeah.
So if I give array of -1, I get 5, which is the largest element. So if the question is find the largest and the smallest element, I will get correct answer. But I want to find second largest. So I give array of -2, that gives me 4.
Okay, that is why minus kth. Okay.
Exactly. I want to find the second largest. Whereas if I want to find the second smallest, it's array of 2 minus 1, right? Which is 1.
Yeah. Yeah.
Second smallest is
Understood
2.
now.
Understood? So if I want to read an
Yeah.
array backwards, I have to use negative numbers. This is 1, -1, -2, -3, -4, -5. And you can check that also. Sorry.
Okay.
Yeah. Okay. So this is how to read
Yeah.
array backwards. Okay. I hope everyone else was
Thank you.
listening. This is an interesting program. So this is good to have this practice of how to read elements in array. Anyway, please try the program which I gave also now. I hope this is clear to everyone. I hope so. Now you can try this. If you are not having a question, please mute. It's kind of distracting. Please mute unless you have a question because it's very distracting. I hope you guys are trying. How many of you are trying the program? Please raise your hand. There's one hand already raised from that time. I don't know what it's for. Please raise your hand if you're trying the program. If you have any doubts or want me to explain it again, I can. Okay, good. Someone is trying. Where can I access? Wait, what? Is there a question in the chat? Where can I access all the I mean, it's in the Google Drive, right? The link, I'll share the link at the end of the class, but I hope you've been getting the link also inside the Google Drive, all the slides and also the programs, also the solution to the programs, the Python files I'm uploading. So please go and check it there. It's on my website also, so you can go check it there as well. Okay, 28. I don't understand. What's 20? Okay, I'll share it after I show this program. I'll share it towards the end of the class. And anyway, the NPTEL team should be sharing with you the Excel sheet also. I don't understand what's 28 here. Okay, I'll give you like 2 more minutes. Or maybe yeah, I'll give you a few more minutes to try to do this program, and then I'll show you the solution to the program. Have any of you got?
Like, do
Yeah, yeah,
you have
please.
any idea if the final exam would be like objective or there will be coding
I am
like
not. I
exam?
have no. I have no clue. I am an external TA. I just conduct these sessions. That's all. Maybe you can ask in the discussion
So,
forum, and they can tell you.
okay, okay, thank you.
Yeah, my job is just to solve these past papers for you so that it becomes easy for you. I'm sure it will be similar, but I don't know if there will be MCQs, programs, those format. I don't. You can ask in the discussion forum or something, and they can come. But please don't study just for exam. Programming is a very good skill, so try to study regardless.
Yeah, but sometimes some programs take a lot of our time, and like otherwise, so we have Google to our help or something, but in exam, then we won't have anything, and
Yeah, you should not
we
be
may get
googling.
stuck. No, no,
Uh,
I am saying we may get stuck
Stuck,
somewhere,
huh?
and then the whole thing.
Yeah, so
Sometimes it takes time.
that's why we have these sessions every week, so you can have enough practice before your exam. So yeah, please ask in the forum if there will be programming also. I think there should be programming because it's a programming course. It doesn't make sense without programming questions. But please ask and find out the answer. I am not sure, so I will not say anything.
Okay, thank you.
Yeah, sure. Okay, so should I go to the solution? Are you guys able to solve this program or do this program? Anyone who's trying, please put your hands up. Okay, okay. People are trying. Then I'll give you 5 more minutes. Please mute if you're not talking. I'm waiting. I'm waiting for you guys to try the program. Have you tried it? So someone said they were trying, so that's why I'm waiting still. Have you tried the program? Are you able to do it? Vivek, are you able to solve the question? So in my classes, if you don't know, I give time for people to do the program because as I said, you should always try the program first. So I asked and someone is still trying. So did you try the program, Vivek? Okay, since I think I've given enough time, we can go to the solution. Please always try it on your own. And that's why I give this time. So, okay, let's go to the solution. I hope you can all see my screen.
Yes.
Yeah, okay, good. So here you can see that we are defining a function called distance. And as if you can see, the condition is such that if the words are of unequal lengths, then just return -1, right? Whereas if they are of equal lengths, then only we have to do this full whole process. So that is the first condition is this. And essentially you are giving all the letters as A, B, C, D, F, G, etc. So basically the index of each letter tells you the position, right? So this is 0, 1, 2. And if I take the difference of the indices, that will give me the distance that I have defined here. Okay. So basically the size I'm taking as length of the word 1. So this is if the word is not the same, then I do all this process. And you can see that I'm going through the process, and C1, C2 are basically what are the letters between for the first letter. So we have to basically find the distance between each of the letters, right? First the first letters of each word, then the second letters of each word, then the third letter of each word. Similarly here, first I take the first letter of each word, then I find what is the index of each letter, which means within this word, what is its index, and take the difference. And that gives me the distance as defined by the program. And then you keep adding to the distance essentially. And finally, you return the value. So here you can see that the distance which is calculated for the word dog and cat is 28. So please, if we now try to put that, okay, wait. Let's try to run the program. Let's put dog and cat. You can see that the answer is 28, what we expect. Okay, so this is how you do it. The important thing is we were able to assign the letters to an index in an array. So if you give letters dot index like this, it basically tells you the position at which that letter is coming in the index in the array, right? So basically, if I give letter dot index of C1, it gives me the position where the letter where this particular character is in this alphabet, right? And that's how I'm able to take the distance so that difference so that I can find the distance as is defined by the program. Does anyone have any questions? Vivek, I hope you're happy because you were asking about the question. Others, please, who have tried, maybe you have done in a different way and were you able to get it? I hope this solution is fine for you all. Okay, I see someone giving thumbs up. That's good. Any doubts in this program? It's not very complicated. The main thing is to identify that you can associate each letter with a number so that becoming taking the difference becomes easier. Okay? Any
I
doubts?
have this question.
Yes.
Yeah, I have this question. Like we were using return to return one when we were counting one per iteration. Then return zero when it will not be returning anything. So what is return -1 here now?
Return -1 just means that it returns the value -1. So suppose I give here, it gives me
Okay.
-1.
So it
And that is
will.
what it has given, right? If the distance between the two words is
Okay.
-1 if they are of unequal lengths. So that's why.
Okay,
because
so
it's given in the
not
question.
okay. It's not being used as a count here. It's not
No, no.
being used for counting. It's returning -1 as such. Okay.
Why, how will you count with -1, right? Why do you return 0 or 0 when you're counting? Because if nothing is counted, then 0 is the count, right? So that's why you return. So
Okay.
please don't try to remember things like this, like, oh, count means return 0, count means return 1, count. Then you will always get confused. Try to always understand the logic. Why was 0 returned in the first place? It won't just be like count. There will be some particular reason. Do you understand what I'm saying? If you try to
Yeah,
mug
I
up,
mean,
like when there's count, it returns 0 1. If it this, then some case like this comes, you'll get
no,
confused.
I mean to ask, like, is return a function in Python?
Yeah, return is like, it's not a function. It's like, yeah, it is a command which returns a value. So if you have a function,
Okay.
return means the function returns you that value. So here it's returning distance. What does that mean? It calculates distance, and if I call the function, that is a value that the function has. That's what return does. So
Okay.
we have return in almost all our programs, right? For example, here this returns the sum of the Fibonacci terms, because that's what this function is for.
Okay.
If I don't return anything, the function will run and it won't print anything. How will I know if function is correct or not? Do you get it?
Yeah, so it's giving the output of the function.
Exactly. That's what return does. So return, if you see, return just gives you the output of the function. So return is not a function. Like for is not a function. For is a keyword. It does something. Like that return is a keyword which does something in Python.
Okay. Yeah.
Okay.
Thank you.
Great. Okay. So I think this program is clear. It's not very difficult. And, again, if you see long programs, don't get scared. Usually the solution is quite simple. Go to the next program and I'll give you some time to solve it as usual. So this is a program. So you have a dictionary. Dictionary, if you remember, we spoke about last time, which is keys and values, right? So you have a value which is associated with a key. And that's how a dictionary is defined. Basically, you have a dictionary called P, which is a dictionary of father-son relationships with the following structure. So here they have given some examples, like Jahangir is the father of Akbar, and so on and so on. Sorry, Akbar is the father of Jahangir, and so on and so forth. So if Jahangir is the key, then Akbar is is the value, which is his father, and this is true of every key in the dictionary. Now you have to write a recursive function. Recursion, again, here recursion means that it's function which is defined in terms of itself, which is named ancestry and accepts the following arguments, where P is the dictionary, whichever of relationships. Present is the name of the person, which is a string. Past, which is a name of a person. And whenever you call this function, then it should trace the entire ancestry from present to past. So suppose I call the function like ancestry of P, Jahangir, Babur, then it should return this list to me like Jahangir, Akbar, Humayun, Babur. So you can see that the full sequence is returned to me. So in more Python terms, L of I is the father of L of I minus 1 for I contained within the list, with the condition that L of 0 should be present and L of minus 1 should be past. So the last element should be the past, first element should be the present, and you should call from the list. So this is what you do. This is a recursive function. Please try doing it. I'll give you some time to solve it, and then please let me know if you are, want me to explain the program again.
Hello,
Yes.
hello, ma'am. Say I have a question, and not regarding this. I mean, whether it is compulsory in order to attend this problem section.
Compulsory for what? I
I
don't
mean,
understand.
whether it is necessary in order to. I mean, whether it is necessary in order to attend around 2 hour of this problem solving section. I mean, whether it use as a qualification guide in order to attend this examination, just like writing down the assignment. Is there anything, any criteria like that?
You can check. I don't think there's a criteria like that. This is for your benefit. No one is forcing you.
No, no.
But yeah, you can check it if it is at all there. I don't think it's there.
I mean, just like assignment. Ma'am, assignment itself is really compulsory. Just like that, is it compulsory in order to attend this problem
As far
section?
as
Because
I
I have an
know, this
exam tomorrow.
Oh, as far as I know, this is not compulsory. You can check if they have those rules, right, in the exam. You can just check once. I don't
And
think this is compulsory.
oh, just like assignment, I thought that well, it must be compulsory. So that's the main reason I asking you.
I don't know,
I
but they
mean,
ask us
I
for the
just
attendance every week. So I do give them the attendance number of people who are attending. I do give them, but I don't think
okay.
it's compulsory. You can check once with the NPTEL team. But yeah, this is for your benefit only. Like, don't feel forced to attend.
No,
And
no, no.
there
I
are
usually
three sessions in a week.
uh,
So if you miss one of the sessions, you can try to attend the other sessions also.
okay, okay. Thank you very much.
Are you guys trying the solution? Are you guys trying to solve the question?
Yes, yes.
Yeah, okay, good. I'll give you some time. I'll give you maybe 10 minutes and you can try. Okay, I think did you get the solution? That's good. That's the output of your program. Then maybe we can move to the answer. Those of you who are still trying, you can continue, but I'll just show the answer for now. Anyone who's still trying, or shall I go to the answer? Okay, guys, shall I go to the answer?
Yes.
Yeah, okay. Okay. Fine. Please keep trying if you didn't get it, but I'll just show the answer so that we can do at least one more program before the session ends. Okay, so this is the second program. So as you can see, we have defined a function called ancestry, which accepts three things, which is your uh, P, which is your dictionary, present, which is basically the present person, and past, which is the past person. And you can see that this is actually a recursive function because it keeps calling back present and past, and keeps on calling off what is p of present. So it keeps like taking the previous the basically the function is defined in terms of itself. And why this p of present works is because we are having a dictionary where key values are there, and the value of each item is the sorry value of each item is basically the father of the key, right? So you can see that if Jahangir is the key, then Akbar, his father, is the value. And similarly, if I now check my program, you can see that I'm calling the dictionary of the key, which means I'm getting the value. So dictionary of the son gives me the father. That's how it works. So yeah, we can try it out. And this eval basically gives you the evaluates something in terms of the dictionary. Okay, so this is how you do it. Let us try just entering it. So dictionary will be whatever. Let's try to just copy paste it. Okay, sorry, it didn't copy paste properly. Let's try to run it again. Okay, okay, I guess I have to write it manually. I didn't want to do that. Can I just write A B? Hmm. I'm supposed to write this A B. Hmm. Okay, wait, I'm not sure. I'm facing some issue. Just give me a second. Hmm. Do you guys know how the dictionary works? I forgot how exactly you. Um, I think you have to enter it like. Give me a second. I'm not very familiar with dictionaries. I forgot how exactly it was worked. That I wrote this a few days ago. Or if any of you can help me out, I forgot how exactly it works. Hmm. Okay, let me try to find this out. Give me a second. Uh, mm-hmm. Oh, okay, okay. I think I got it. So wait it. I have to write it with the braces, I think. That's why there was an issue. Okay, let me just share again. Screen.
Mm.
I don't know what's the issue. This is how they entered it last year. Let's see the last year's George.
I think only the
Ah, okay.
key has to be in quote, value is not in quote.
No, no, both are in quotes. I think here I made some error. Now it's working. Okay, now it works. Okay, let's try it again. Sorry guys, I am not very used to dictionaries, so okay. A B B C D D I give D A. Huh. Why does it work? Okay, I don't know why it's not working with A B C D. But okay, this is from last year's thing where I got the question from. So if I use their input, my God, what am I doing? If I use their input, somehow when I'm entering it's wrong. I don't know why it is, but if I use their input and I just use the same thing, then it does return for me. So there's something wrong with how I was entering the key and values or something. I'll look it up and I'll clarify it in the slides or something. But for now, this is how the program works. Program is now quite simple. You're just calling the function again and again, so you can keep adding the previous parts again and again to the from the dictionary. Okay, there is. I'm not very familiar with dictionary, so I don't know how exactly is the format to input it. That's why I had some issue. Sorry about that. But I think other than that, the program is clear to everyone. Otherwise, if you know some other way to enter dictionary, this is one of the methods I saw. That's why I used it. But again, I'm not very familiar, so I was not able to use it properly. But I hope other than that, it's clear to everybody. Yeah, okay. Cool. So maybe we can go to doing
Yeah,
one last.
can
Yeah,
you share
please.
the code in the chat?
No, I mean, I'm sharing all the codes in my Google Drive, right? So you can find it and you can download it from there. Okay.
Okay, okay, thank you.
Okay, great. Fine. So let's try to do one more question, or is it too long? Okay, this is quite a long program. So then maybe I can just explain the third and fourth programs and you can try it out yourself. Always will provide the solution in the Google Drive, so you can also look at the solution. So here this is a program again which was given in last year, which is about Fibonacci. So again, Fibonacci series we just saw, but this is a different kind of Fibonacci the series that we have to compute. Here you can see that Fibonacci is a young resident of the Italian city of Pisa. And basically there is a game and you have to calculate how many sequences are part of this game. Okay. So Fibonacci either likes to climb the steps one at a time, two at a time, or three at a time. So he wants to find the total number of ways in which you can climb n steps if the order of the steps matter. For example, if you want to climb three steps, you can do it in four different ways. You can climb it as 1 1 1, which means you're climbing three, so each step at a time. Then you can climb it as 1 and 2, which means you first take one step, then you take two steps. Or you can do it as 2 and 1, which means first you're taking two steps, then you're taking one step, and then you can do three. Just one move, you're just jumping to three steps. So like that, you can, for each number n, you can find how many sequences are there. So the point is to note that you have to count if each time you can climb only one step, two steps, or three steps, how many such sequences are there. So for example, for n is equal to 3, there are four ways of doing it, right? For n is equal to 5, there are many ways of doing it. Some of them are here. Like that, you have to find out what is the number of ways in which the steps can be climbed by him. So again, this should be a recursive function, because you have to, every time to climb 5 steps, you have to climb 4 steps. To climb 4 steps, you have to climb 3 steps. Like that, you have to keep calling the function again and again. So the first program. The second program that I had is a simple program which is about LCM and HCF. You have to accept two numbers as input, write a program which uses recursion to calculate the LCM of the two numbers, and you can use this relationship to find the LCM and the HCF. So I think if I give you time now, it will be a little late. So let me do one thing. I will share the programs with you on the Google Drive. Please go through them. And let me just go to my first slide. You can always mail me on my email ID if you find any difficulty in these programs or any of the programs I've given. As I said, please don't mail me about the assignment. That alone you should not do, because that is up to you to try on your own. But other than that, any programs which are used in this class, or anything, you can please mail me. I'll just paste also the link to my GitHub in the chat, because there you can find all the lecture notes and the Google Drive where the programs are. So let me just paste it in the chat. Please go to this website. If you go to this website, you can see, for example, all the YouTube videos of this course, right? 5 videos so far. And if you go to this link, then you can actually find the Google Drive. You can see that in each Google Drive, each week I have a different folder. If you go inside the folder, you can actually find that I have all the different programs.
Your screen is not visible.
Am I not sharing? Oh, I'm so sorry.
Yeah.
I don't know when I stopped sharing. Sorry about that. So yeah, I was saying that if you go to my website and if you click this link, you can find the Google Drive. Each question in the Google Drive has all the programs and all the slides of every week. Okay, all the MCQs and all the programs, including their solutions. By the way, these are all programs where the solutions are given. You can try to go and look at it. Okay. So these last two programs I had explained. Did you guys see, or was the screen not sharing that time? Please read through the programs. If you have any doubt, you can mail me also. Okay, I'll share the solution anyway in the Google Drive. But before you look at the solution, please try it on your own. The reason that I sit and I wait 10 minutes or 20 minutes, like I had 4 programs. I could have very easily explained all 4 programs one by one and finished the class. But I don't do that. I give you time because I want you guys to try programming on your own. It's very important. So at least once a week, you are forced to try, right? So that's what I'm trying to do. But even apart from that, please try the programs. Okay. So please try the program sincerely. And then if you are getting stuck, please look at the solution which is provided to you. And if you have any doubts at any point, please mail me. Not about the assignment, but about any other matter. Okay. Assignment you should try on your own sincerely. Okay, I think that's it for this week. I don't have anything more to say. If there is no more questions, we can end the session for tonight. Okay, fine. Have a nice night, guys. See you next week, same time. Bye, everyone.